This next section is more around software-defined infrastructure, and I'll talk about it generically, and then I'll specifically talk about SDN because we find this is a fascinating use. We're not an SDN controller, we focus on compute, but SDN creates interesting conditions for us to optimize, and we're seeing quite a bit of interest in that. So let's start from the top though and talk about infrastructure in terms of supply and demand. So this is a Gartner diagram just showing one way to draw SDI, SDDC, compute, storage, networking, and the way they view it, it maps out to a consumption model. The way we view it is that this all provides a set of capabilities, as I've already mentioned. So any infrastructure does. SDI is just particularly flexible in the way it delivers that. So how I can deliver compute or network configurations, storage tiers, all that becomes a lot more flexible when I start putting all these software-defined technologies in there. But the same basic truth applies that still I'm just mapping out a set of capabilities. So that's the supply side of the equation, or since we're at VMworld, and we'll keep on theme, get that set up, that's ready for anything, I guess, to come in. Now let's talk about the demand. And I find a lot of discussions I have lately tend to focus, I like to draw an analogy to SDI to like a reconfigurable conference center where I can make it anything I want, but what I make it really depends on how I'm using it. If it's an auto show, it's different than an IT conference, which is different than a wedding. Where I put the walls, how I cater is all different. And so a lot of people are starting to talk about the fact that this really needs to be driven by the demand. In fact, some people say it shouldn't be called software-defined, it should be service-defined or enterprise-defined. There's all kinds of different things flying out. So from the top, I've got different types of demands. I have, of course, self-service clouds, OpenStack, VRA, that type of thing. That creates a certain type of dynamic request into the infrastructure. I still have SAP modules I'm deploying next month. I need to plan for those. How do I make sure I have space for these new modules, that new HR system or whatever that is? So that still exists. I have migration, maybe more project-based work. I'm getting out of the site, or I need to bring these over from another location. Or even, like I mentioned, existing applications, I might need to take those and reassess them and understand what to do with them. So all of these things map out to a set of requirements. And again, I've already kind of covered some of these concepts. What are the resource requirements? Software, SLA, storage. If that's customer data, that might dictate where it goes. We're working with a bank now where they have huge jurisdictional issues on where the data goes. So it becomes paramount. And then, of course, it varies by line of business. Certain lines of business, like a card services group of a bank might have all kinds of weird and wonderful requirements that dictates where they go. And really, if you look at this kind of it really forms a pipeline. And it's we start to get into the language of demand management. There's a pipeline of demands coming through. Some of them firing through fast, some of them slower, some of them need to be built out as they're coming down the pipe. And at the bottom, we have a portfolio of supply. So we don't just have one VMware environment, we have dozens of them, and OpenStack, and whatever else, and we're looking at bare metal outside. And so really that's the kind of the way we view the world, is that we've got a portfolio of supply and we have this pipeline of demand, and we need to scientifically analyze them and link them together. And that's the real challenge. That's kind of that's the other way to put the problem statement. Earlier I showed a Tetris problem statement. This is kind of the more macro level problem statement, that I've got a major hosting issue. And so, we view it as the solution to this, as I've already mentioned, policy and analytics. And I'll kind of walk through both these in a little more detail now to talk about how that is bridged. So on the policy front, I find lately we tend to get into some pretty deep discussions just around nomenclature. So we like to use the word codification. It's a nice way to capture how you want the environment to operate. It's the lease agreement. It's you need certain things from me, I need certain things from you. Let's write it down, and what you need from the infrastructure. And as I mentioned earlier, there's a lot of confusion because we find some vendors are calling templates policies. So I need to turn on a web application and use open port 80, and I need those to connect, and they call that a policy. And in our view, that's not a policy, that's a blueprint or a requirement. The policy is, again, how it's met by the infrastructure. So we see all kinds of confusion around those phrases, but in our view, again, the policy is the rules, not the request. And the goal of the policy, again, should be to achieve three things. We want to basically put the right amount of work in our environments, so we're not buying twice as much hardware as we need. We want to do so without incurring unnecessary risk. I won't say no risk because that's not possible. It's what's the acceptable risk to run something, and oftentimes that might be the first requirement. And I want to automate all this stuff. These are kind of the if we talk any organization, these things kind of bubble up as our kind of top level distilled requirements. And so when we talk about density, this diagram kind of neatly captures the trade-off that happens. So if we look at density across the bottom, with the left-hand side being I run every app on a physical, the right-hand side being I got a 100-to-1 stacking ratio or something like that. The more I put together, the more I save. That's pretty obvious. It's kind of a 1/x relationship, or almost 1/x. But the higher my hosting risk. So anytime I share anything, I get some risk. People are talking through the same NIC. That's going to do some level of risk. But as I put more and more together, I might start running out of memory or having other catastrophic problems. So for a certain type of workload, there is an optimal control point that implies how densely I pack those workloads and a corresponding cost for hosting them. And if I go either side of that, I either get a lot of cost or a lot of risk in a hurry. So picture an environment that's running a 10-to-1 and it's running well, but it's right on the edge. If I push it to 12-to-1, it's going to start having all kinds of problems. So it's kind of nonlinear. It happens very quickly. But there's not just one control point. There might be different ones for different SLA levels is a good way to think of it. So if I have a non-critical production, like an HR system, maybe I'll pack them in a bit tighter. It doesn't have quite the response time requirements. The user will come back in 2 hours if it's going slow. Or dev test, if my compiler runs out of memory, I'll start it again. I'll kick it off again, whatever that is. So we find that there's different control points based on what you want the app to be doing and requirements of the apps. And the problem is most people are way up that curve. That's why I showed you that visualization, that kind of 0.5 to 0.7 number really equates to being way further up that. You have probably twice as much infrastructure as you really need. So that's been used as a form of risk management for some time, but you can't keep getting away with that because your Amazon's a lot cheaper. If you run things twice as expensive as you need to, you're just never going to survive. So these really show that the impact of policy. You're really codifying the operational targets to match the needs of the workloads. And again, that's a very important part. So we see some customers setting up high density versus high performance, or highly compliant environments, like PCI compliant environments for certain workloads. And that's all driven by policy. And just to kind of drive home a little more detail, if you look at some kind of high level areas that you would want to codify, I might say for critical production workloads, I want them to perform well. I need lots of spare capacity kicking around for failures, N+2. I really need to make sure I separate lines of business or data or whatever that is. I might even have different licensing models that in those environments than I would in a dev test environment. Like I said, where you just stack them right up and no high overcommit ratios, no holdback for failure. Licensing is a completely different ballgame in dev. So these are just examples, but we do ship these 6 out of the box. They're kind of starting points where we see what people are doing and what people tend to overcommit in our major customers, and we say, okay, that's a good starting point for these policies. But metaphorically, you can think of it like knobs that you turn. These are the levers you can pull to make the environment behave differently. Even the same hardware with the same hypervisor will behave differently if I start messing with these policies.
Do you integrate with tagging and like vCenter or anything like that?
Tagging, yes, generically. We pull in business tags from
like being able to
CMDBs.
Tag certain things, be able to correlate back and forth between, like in vCenter, if I have some tags defined on storage or whatever. Is there a need? I mean, is there even a need for it? Or I could see the two coming together.
Yes. So we are in the process of looking at getting tags out of vRealize. Okay. So there's vRealize Business and there's also vRealize Ops, which has tags in it. And there's also some just in VMware kind of more bare. We find though system of record discussion, a lot of times they should really be synced off another system of record, like a CMDB or something like that. To be the so we usually sync from some authority on, is it a production workload, who owns it, all that kind of stuff, and that drives all our rules as well.
Okay.
So we absolutely can drive off tags, but the VMware ones, again, in an ideal environment, would be off.
And type tags and things like that.
We also pull up the DRS rules
and stuff like that.
Yeah. So we have a very extensive attribute system that you can model all those things, and usually they can come in from multiple, or Excel spreadsheets, they can come in from all over the place. So initially you may not do that, but as you mature, you might say, I want to tag whether these are production or dev test or batch jobs, and they might have a different policy attached to them because of that.
Because I'm just thinking scenarios where maybe I'm defining storage policies from a storage perspective, and I want to define the policy from your product, but somebody comes in and deploys a VM, and they select the tag that I've defined that I'm thinking is matched with what is here.
Right.
That I might say this is a silver level storage tier or whatever, and they deploy it outside of this having the control. If they can sync together, like if I could say this tag, have the policy drive itself off of that tag.
Yeah, no, that'd be the ideal scenario.
Okay.
Absolutely, yeah.
So that is in it. That is there.
Yeah, that's the way we generally operate. Is
Okay.
that and there's all kinds of different types of tags, including the storage side and the storage policy and the thin provisioning policies, that kind of stuff.
Okay, cool.
But it's key that we not to see what the workload pattern, but also we know more and more about it to get more and more advanced control policy.
From a technical point of view, do you only connect to vCenter, or do you connect to your storage box? Do you connect to applications, or?
So we connect. So again, the different type of providers are different. So vCenter is a great source of data. We get data from Hyper-V. We talk to the host in that case. We talk to KVM and OpenStack to build the picture for that. In Unix environments, we talk to HMCs and LPAR. So each one is different. VMware happens to be the easiest because it has a nice API to give you everything. Rev with its RevM is nice as well because it actually has something you can talk to ask for data. On the storage front, we just released NetApp OCI integration, and so all the platforms it supports, they're all modeled in us. And there's another one, it's not announced yet, I don't think, so I won't mention the other one we're doing very, very imminently on the storage front.
Okay.
Yep.
So you do connect to storage boxes next to all the hypervisor or vCenter or?
Yes, yeah, that's an important part of the picture as well.
Okay.
Yeah.
That's cool.
Do you allow people to have REST API access? So if you wanted to pull some of that information back out, or
push it in.
script it, or push it in with
I want to make
scripting?
my own.
Yeah, so we do have REST API for that northbound interface into us, and we do also. I'm not sure that's part of your question. We do see customers with other sources of data that are API enabled as well. So one of our customers has a storage system where they aggregate storage data. We just pull from it, so we don't even talk to the endpoints. So it's great when somebody's organized enough to have a system of record for a certain type of data, and we just start to feed off it. So we don't want to reinvent the wheel. And then conversely, once it's in us, we try to be as open as possible as far as if you want to pull stuff out of us or ask us questions or inject things in. That's what our API is focused on. And again, I'd probably be good to have one of these giant flow diagrams showing how it all fits in, but perhaps another day we can cover that.
Sure.
So let's just kind of get back onto this. I want to make sure I don't run right off the end of the time here. So we've talked about policy. We've got a way now to codify the way these two things operate, and then next is the analytics. And I'll just go a little faster through this because I've already covered quite a few of these concepts. But let's just talk about a VMware environment. That's obviously the topic of the day. So I've got some clusters. Just pretend they're bigger. Pretend there's more of them. This is PowerPoint. And we've got VROPs and vCenter active, and we've got DRS, of course, moving things around. Back to that control theory slide. This basically gives you a kind of a reactive level of operation. So when we talk about that Tetris, when we see these environments running with all these pieces in it, that's where you get that the kind of jumbling of the Tetris blocks, fragmentation, contention. Things will bump into each other, and when they do, DRS kicks in, and that creates some volatility and the software inefficiency. So again, consistent with that control theory slide, if we add in a more deep level of analytics, we have our policies. We also pull up all the DRS rules. So we find a lot of our customers, people will put, for certain reasons, things in DRS to pin things down. We analyze it. We come up with the optimal plan. We also say, well, now there might be some subtlety in what we did there. For example, containing SQL servers to certain hosts. So we also inject that back into the infrastructure. So that's very important because what we're doing is saying that we're going to make DRS a little bit smarter. It still runs very quickly in real time. It just knows a little more, some more boundaries to work within when it's doing its job. It will do less as a result of us analyzing, but also when it does, it'll be a little bit smarter.
But also with trends.
Sorry?
Is it also acting on trends?
Trends in the data?
Yeah.
So we do, absolutely. So
yeah, exactly.
Yeah, so we will see that if a workload's getting busier, it's no longer, well, first of all, the basic thing is we're going to see that that's getting busy at 5 p.m. and so is that one. We're not putting them together. So we're going to basically be intelligent rather than waiting for it to happen and move it. We also see that, that's steadily getting busy over time. So we model organic trends.
What about if you've got month end that ramps up every month? So let's say you've got month end that goes up by 150% every month on these three clusters. Will it migrate services before the month end?
Yeah, so it'll see that as well. So the policy is very interesting. If I were to pull the policy editor, you have a lot of control.
back, you know what I mean?
Yeah. You can basically give it a very large window and say, I want to look back 95 days and look at all and build an envelope of operation and understand these patterns, stuff like that. So yeah, it basically it's quite intelligent as far as it deals with the micro. The ones I was showing were kind of 24-hour time of day curves, but it's also looking at the macro level curves. And again, I think that's important for that deliberative control notion, right? We can learn from history. We've seen what happens. We see that happen every day. And we can also tell you that, you know what, you don't have enough space this month end coming with those new bookings coming in. We model the organic trends saying everything's growing at 10%, plus you've got a whole influx coming in, you're not gonna make it. So that's really the only way you can come up with that answer. You can't just look at the last few minutes of data or the last 2 hour data. It's not gonna.
Is there a maximum amount of time you can look?
Well, from a practical standpoint, so we keep all our data in a very highly efficient compressed format for years. So you can have 5 years of data and the policy can say look back 5 years. Practically speaking, nobody really looks back that far. You want to catch the last year end.
Right.
And it's different for the different colored areas of that diagram. Like the yellow zone has a longer time frame than the red zone. You want to bump up quickly if you see something starved. You don't want to bump down unless you've seen a whole operational cycle. I know I'm pointing at the screen that's not up. But yeah, so you have a lot of control. The policy is very detailed. You have a lot of control saying, go back this far, take the 10th to 90th percentile by sample or by day, use sustained activity within that. It's pretty sophisticated what you can do. So that's the supply side optimization. If I move on up the chart here, now let's talk about the demand management. So let's say I have a new request coming in. It's VMware environment, so let's pick on VRA. Somebody's asking for, these 6 VMs with this spec. Now the problem with not just VRA, but almost all the cloud management platforms or infrastructure platforms is that they're not very good at figuring out where to put stuff. They're good at provisioning and the process of orchestrating and turning them on, but there's round robin is what VRA uses. OpenStack uses chance with kind of filter layered on top of that. So they don't really look at what's already running in these environments. We have customers saying, I already have HR running over there. Can I just put them where they are or keep them away from that? Put them on the DR site. It doesn't look at whether the environment was designed for that kind of workload. If I have high density and high performance, well, of course it'll run in a high performance, but high density is fine because it doesn't need more than that. So it'll give you the penthouse when a regular hotel room will do. And when it hits the environment, it still relies on DRS for placement. So what we do is, again, as you've probably already surmised, that will call into our API dynamically and say, Cirba, where do I put this? And we'll say, well, based on all the numbers, put it in that environment over there. And interesting happens when you do that. Interesting thing happens. The Tetris analogy kind of occurs at a very high level at that point. So what happens is if I have all these environments and one's low on memory and one's low on storage, it looks at the profile of the demand and will score better in the one that has the right mix of resources. So it will actually level the demand globally. It will actually start to reduce primary constraints across the infrastructure. So, and that's a pretty powerful thing because again, we see all kinds of environments that are out of storage but have plenty of CPU or out of memory or whatever. This starts to do that at the global level, as well as making sure that you're in the right place and it's designed for you and you're compliant and of course it automates that step which we talked about earlier. Layering on these other types of workloads. Again, if you look at something like a cloud management platform, they're almost useless for this kind of stuff. You can't book capacity next month through Horizon or one of these UIs. They don't model forward in time. They don't say what's going to be in there or what new storage will be turned on by that point. So we also model the inbound supply and say, yeah, new blades will be installed next month. So they don't really have that future modeling. They don't understand how to assess an existing workload. They only start new ones. So again, that's where that comes through us as well. So in our customer integrations, all that stuff hits us long before it ever hits the provisioning systems because they don't really do anything on that upfront process. So again, this is the diagram really showing that whole pipeline of demand against the whole portfolio of supply. That's it, kind of in this case, in a VMware construct. And again, as I mentioned earlier, most of our customers have all the VMware products, and it's still there's this piece missing. That's that brain in the middle. What about TOSCA, you ask? Well, we do have customers that are using TOSCA. We've been following this. I think it's still a bit early in the standard, but it seems that people are picking it up. It's fairly generic in its description, but one of our customers in particular is doing something interesting with it. They are feeding us. It's a homegrown portal, TOSCA templates, there's a parser, and they give us that demand just on the fly through the API, the spec, and we answer back with a very detailed answer of what site, what technology, is it VMware or OpenStack? They also do bare metal the same way, so VMware, OpenStack, and bare metal all happen through one call. And say, yeah, that big Oracle server that needs 16 CPUs, that goes to bare metal. That will happen automatically. What hypervisor, what cluster or availability zone, host aggregates, all that kind of stuff. So it all comes back and flows through. They're using another product for the actual TOSCA template parsing and the provisioning. But that just kind of gives you a feel for when you start to reach a high level of automation in this, that's really just what happens. It kind of flows over and flows back. And so to come back to this diagram, so now I have the ability through policy to talk about macro, where things go, at the micro level, where things go, how to allocate resources, how to minimize my software costs, all those good things. And when I analyze that, we can then drive very precise answers back into the infrastructure. Again, where to put stuff, how big to make it, host level placement, and we get some very, very accurate forecasting as a result as well. We can actually look forward very accurately. We have some customers that are saying we model 5 quarters out. So we can actually start to put in more bulk bookings on the horizon and give it, again, you can save an awful lot of money by not buying hardware if you don't need to yet, just by deferring hardware purchases. So again, scientifically aligning supply and demand to optimize the density, drive automation. I think cover that. Now this is the last bit, and there's only a few minutes left, so I'll make sure I get through this. SDN. So this is a fascinating topic for us. So we focus on compute. We look at the I/O and all the other conditions, but really we're talking about placing VMs. But if we stick NSX in the picture here, and we also work with Cisco ACI. We're a partner of Cisco as well. That lets you fool the VMs into thinking they're on the same physical network, the same layer 2 switch, when really they could be spread out everywhere. And if you have Arista networks or ACI with 2-tier networking, all of a sudden you've got a lot of options here for how the VMs are all kind of plugged together. So from an SDN perspective, that gives you a lot of agility. You can configure networks very quickly. That micro segmentation, there's all kinds of things. The way we see it, and some of our bigger customers are driving this, is it makes a bigger game of Tetris. Now that I have the ability to abstract that out, the cluster boundaries are no longer as meaningful. VMs can kind of go all over the place. So all of a sudden now my optimization space becomes huge, which is great because I can get much higher efficiency, but don't try and figure it out manually. Or DRS won't do that. It requires, again, a pretty complicated analysis to figure out now across all these boundaries. A lot of the announcements this morning were more around just exacerbating this problem. Now I have long distance ability to move things, bigger aggregation pools. It's all about making big pools, which is kind of the goal, but the challenge it creates is how do I deal with that? So SDN in particular, I mentioned this earlier, it requires thinking beyond the cluster. The clusters were a convenient boundary where things can't move outside them automatically, so I can use them for all kinds of things. Now I need to kind of expand my thinking. I did start looking at that large sections of infrastructure, but I still need to look at what the constraints are, and this is critical. So it's still possible to get too far from your storage, or go through a VXLAN tunnel accidentally and be off on another data center. You can't let that kind of thing happen. Workloads can touch each other that shouldn't be near each other. That's in some of the big organizations. Licensing. So I love this example. This is a fascinating one. So if I have a SQL server in a VM, I have to license all the hosts that VM could go on. So if I deploy SDN, I have to license my whole data center, because it could theoretically go anywhere. So unless you have controls in place to say we're going to contain it and program it and not let it out of the boundary, you're going to just incur all kinds of costs. So it's really powerful, but it needs control. So again, it's more constraints, more what we call proximity rules. Things need to be kind of near each other. You can no longer rely on them being in the same swimming pool. It's all interconnected now. But the prize, even higher density, even higher automation, and lower unit cost to host a workload. So we think there's a big prize, but you've got to be careful getting to it. So this is what that looks like in our product. I showed this earlier. I showed the top 3 sections. That's kind of the compute. The clusters, the hosts, the guests. The bottom level are what we call sensors. That's where we see storage. How many IP addresses you have left, NSX switches. It's other consumable resources or KPIs. We can model things that you draw down or things that are indicators of status. So here's some NSX VXLANs. And if I click on one, I can see the VMs that are part of that VXLAN. So I can now analyze those as a unit. That might be an application. I can place it atomically and say, some customers call it fill or kill. If I route that, it all has to go into one environment or none of it does. And I can analyze it, reanalyze it as well. I can say, well, take that and find another home for that. Reanalyze that, reroute it somewhere else. But this environment's getting full. I want to put it somewhere else. And by also modeling the transport zones, for those of you familiar with NSX, so we know the boundaries of what a vMotion can do, we can say, well, as long as we put it anywhere within this transport zone, it's just a call away. We can just vMotion it. If it goes outside that, that's a bit different. So by modeling the mobility domain and the VXLAN boundary, you can start to optimize NSX and Cisco ACI on a large scale. So just to wrap that up, I talked about unit cost. In this context especially, I find it's pretty important. So SDN has all this value about configuration and microsegmentation, and again, all these things. But the problem is when we try and make a business case around that, we see some people struggling because it's really expensive software. You know, SDN is expensive to buy, and it's kind of a soft dollar ROI. But if you combine it with what I've shown, you say, well, no, it's also going to save you a pile on Windows licensing, and you're going to be able to buy it, third less hardware. It pays for itself. That huge $10 million expenditure on NSX pays for itself many times over. And also, of course, in general, just watching the unit cost is very important, because if we start to look at now, what Gartner called hybrid IT, we see customers saying, well, I showed an example of this, on-prem multi-stack, I've got on-prem bare metal. Now I start to have off-prem bare metal. So we do a lot of work with IBM, and we are part of their cloud builder program. So we run software. So we're saying, well, now we can start making decisions even into those 10 blades off-prem. That's the same analysis space. We can also say, well, what about vCloud Air or Amazon or all these other offerings? And I just put a little disclaimer there. We don't support all these things right out of the box right now, but they're coming very soon. All of this becomes a space that I want to optimize. And so by analyzing it, and bringing a science to this, that's basically where we see everything going. We see it's going to become a necessity to automate this, to codify it, and automate the decision-making process as these things emerge. And I think they're just going to emerge faster and faster. And we see people just starting to come out from the center all the time.
So I had one question, and I think we're
okay.
close.
And that's the end of the slide deck, by the way. So.
How do you handle like availability zones if I was to deploy? And if I did a massive AZ deployment, instead of running one vCenter for all the AZs, if I deployed a vCenter per rack,
right?
How does that play into this? I mean, how can I add a top layer? Does this allow me to add that top layer to all those vCenters to be able to combine all that compute?
Yeah.
Or is it better to look at it from just one vCenter for all my AZs?
So to us, we don't care if it's coming from multiple vCenters or one. Like you can have 20 environments that could be all one vCenter or coming from 20 vCenters. For our analytics, we don't care, but it might dictate what you can do from an action perspective underneath the covers.
And that's what I'm thinking. As you come from the top down, if it's one vCenter, it's one massive amount.
Yeah.
I mean, what vCenter, data center, however you
structure it in there. Yeah.
Cluster, right?
Yeah.
But if I'm doing a vCenter and then maybe one data center is actually an AZ name or zone, how I can control that from the top down where it's actually a massive pool of resources, but I just have...
You've kind of made logical boundaries.
Yeah, you have to make a lot of decisions.
You want those
at that
boundaries.
point, right?
That might be more like a host aggregate, where within a group I might have a certain
open
capability zone, right?
To be able to do some of that stuff where they can just say, especially when you get into multiple VMs for availability, right? I mean, the whole point, that it can just spread them out.
Spread them out, yeah. So we can model that. Again, we're not too concerned by the structures that are underneath. We will model it however way you want the pool to look.
Right.
And in general, what we would say theoretically is that the bigger the pools, the better. I mean, the less constrained and the bigger the pools, the better off everything is, as long as you model everything you need to. So if you can get by with one giant vCenter and not strain, then that's so much better. But for us, it's kind of transparent. We don't really care one way or the other. It's just you set the capability models.
Thank you.